In this demonstration, we're going to spend some time working with storage spaces on a Windows 11 system. First, I need to make sure that I have extra hard drives installed in the system that I can use for storage spaces. Let's open Disk Management. You can see that my Windows operating system is installed on disk 0 and it's using the entire disk. I also have several other blank hard disk drives in this system that currently aren't allocated to anything. They have no partitions and no volumes defined on them. I have disks 0, 1, 2, 3, and 4. They're each about 931 gigabytes in size. With these storage devices installed, I can go ahead and define storage spaces. I'm going to open the search tool and type Control Panel, then click on Control Panel to open it up. Within Control Panel, I need to go to System and Security and then click on Storage Spaces. The first thing I need to do before I can create a storage space is to define a new storage pool. A storage pool is composed of multiple storage devices in the system. Let's click on Create a new pool and storage space. I'm shown a list of unformatted drives in the system that I could potentially add to the storage pool. Adding all these disks at once is an option, but for demonstration purposes, I'm only going to add disks 1, 2, and 3 to the pool right now. Click Create Pool. At this point, I have a storage pool defined, but before I can use that pool to save files, I need to define a storage space within that pool. In some ways, a storage space functions like a traditional volume. If you have a blank hard disk drive and you want to create a volume on it, you can have that volume encompass the entire hard disk drive, or you can divide one disk into multiple volumes. You can do the same thing with storage spaces. You can create one storage space out of the pool, or you can create lots of storage spaces within that same pool. Let's begin by just creating one storage space in the pool. We'll use the default name of storage space. We'll assign it the next available drive letter in the system, which is D, and we'll use the NTFS file system. Down here is where we specify what type of resiliency we want to use. In many ways, storage spaces function like a RAID array does. When you select the drop-down list, you see all the possible resiliency types from which to choose. When you select an option from the list, you get a description of what that resiliency type does and how many drives you need. The first option available is to use no resiliency at all. This is like having one large drive. This is kind of a dangerous option because if one of the disks fails, you lose your data. Two-way mirror is a better option. With two-way mirroring, storage spaces writes 2 copies of your data to protect you from a single drive failure. To use this option, you must have at least 2 drives implemented in the system. This option is like implementing RAID 1. You can also use three-way mirror, which causes storage spaces to write 3 copies of your data. This will protect you from 2 simultaneous drive failures. With three-way mirroring, 2 drives in the storage space can fail, and you will still have access to your data. Three-way mirroring requires at least 5 drives in the system. Another option is parity. It's the one I like best. Parity is basically the equivalent of using RAID 5. When you use parity, you're protected from a single drive failure using the parity information that's stored across the drives in the storage space. As with RAID 5, a parity storage space requires at least 3 drives. Let's use that option first. Down here, we see the size of the pool. The total pool capacity is little over 2.7 terabytes, and the available pool capacity is the same. But notice down here, the maximum size is only 1.8 terabytes. Why is that? It's because 1/3 of each of the 3 hard drives in this pool is going to be used to store the parity information, so we can't use it to store data. This means the actual available size for storing data is about 2/3 the size of the entire pool capacity. Let's go ahead and click Create Storage Space. With the storage space created, notice that it's mapped to drive D. If I go to this PC, we have a storage space drive D. Now we can save data within this storage space. I'm going to create a new text document. Let's edit it. We'll type in some beautiful literature and save it. Close the file. Now, because we're using parity for this storage space, if one of the drives in the storage space fails, parity information could be used to reconstruct this file, and I would still have access to it. Now let's go ahead and close File Explorer, and let's look at the storage space itself. Notice over here we have information about the storage pool. We're currently using 6.5 gigabytes of the 2.72 terabyte total pool capacity. Down here, we see information about the storage space that's been defined in this pool. It's been assigned drive letter D. It uses parity. It's about 1.8 terabytes in size, and it's currently consuming 2.25 gigabytes of the pool capacity. Now you might be saying, wait a minute, the file we created was small, so why use 2.25 gigabytes? Well, a lot of that is just overhead for the storage space itself. You can get a better picture of the usage by expanding physical drives. When I do that, we see each of the drives that are used to create the pool and the storage space. One of the great things about a storage space is that if you run out of space for some reason, perhaps you filled it up with large video files, you can add additional drives to the storage space. With a traditional disk partition and volume, you'd have to back up the data, install a new hard disk drive that's bigger, recreate the volume, and then restore the data. That's a big pain. With the storage space, we don't have to do that. All we need to do is add drives to the pool and then change the size of the storage space. Let's go ahead and do that right now. Let's go over here and click on Add Drives. Notice that we have one unformatted drive still in the system that hasn't been allocated to anything. We can go ahead and add it to the existing pool. Click Add Drives. Now that drive is added to the pool, notice that I didn't have to do anything else. I didn't have to back up anything, I didn't have to delete anything, and I didn't have to restore anything. The space was just dynamically added and the pool size grew as a result. With the new drive, we're up to about 3.63 terabytes of pool capacity. Now when we come down and expand physical drives, we see all 4 drives currently being used in the pool and the storage space. Notice that the size of the storage space is still just 1.8 terabytes. We can change that by coming over here and selecting Change, and now we can add some of the new space that we added to the pool to the storage space itself. Remember, even with the additional drives added to the system, we can still only use 2/3 of the space on those drives for storing files. The other third of those drives still needs to be used for parity. Right now, we're currently using about 1.8 terabytes, so we can increase this up to roughly 2.5 terabytes. When I do that, it tells me that the size of the storage space, including resiliency, is 3.74 terabytes. Let's go ahead and change the storage space. We'll increase it to 2.5 terabytes, and we're still using parity to protect the data within that storage space. So that's how you create a storage pool. Before we end this demo, I want to show you another nice feature of storage spaces, and that's the concept of overbooking. To demonstrate this, I'm going to delete the storage space, so I'll select Delete Storage Space. Now we have a storage pool that's composed of these 5 drives, but there's no storage space defined in it. Let's go over here and click Create a Storage Space. Now, here's the thing that I want you to understand. The sum of all the storage spaces defined within a single pool can exceed the size of the pool. We can do this because storage spaces will rearrange automatically so that unused storage in one storage space can be reallocated dynamically to a different storage space in the same pool that needs it. Let's go ahead and create our first storage space. We'll call it Storage Space 1. For resiliency, let's use parity. Now, notice that the maximum size of the storage space that we can create is 2.41 terabytes, but let's reduce that down to 2 terabytes. Now I'll click Create Storage Space. So there's the first storage space. It's ready to go. Since we haven't used all the capacity in the pool, let's go ahead and create another storage space. We'll call it Storage Space. We'll assign it drive letter E, and we'll use parity just like we did before. Now I'm going to set the maximum size to 3.5 terabytes. Remember, I already created a storage space within the same pool that was 2 terabytes in size, and that bumps us to 5.24 terabytes of space. Well, we only have 3.6 terabytes available, yet I'm able to create 2 storage spaces in the same pool, and the sum of the sizes of the 2 storage space exceeds the total size of the pool. Storage spaces is just fine with it. There are, however, certain limits to this feature. It won't allow you to overbook the pool endlessly, but there's usually a viable solution. In this situation, we were able to create the 2 storage spaces, one at 2 terabytes and one that's 3.5 terabytes, which is bigger than the total size of the pool. Storage spaces will just manage the allocation of space between the 2 storage spaces within the same pool. That's it for this demonstration. In this demo, we talked about creating storage spaces. First, we created a storage pool. Then we created a storage space. We ended this demonstration by talking about how to overbook a storage pool.